Good morning or good afternoon, everyone. Um, so, I just wanted to quickly go over and try to answer some of the questions that you had regarding the assignments. So, the in class assignment, which is the visual technique or the dimensional analysis, or the accuracy versus precision question. Um, so, you can answer the questions wherever you feel the easiest. So if you want to answer the question in Google Docs, that would work. If you want to answer the question in your handwriting using Google Canvas, that would work too. Just take a image snapshot and do an attachment that way. Um, if that doesn't work and you want to use any other feature on your Chromebooks, please do so. As long as you get it to me. If nothing works and you want to do it by hand on a piece of paper, by and then just take a picture of it and submit that to me, that would work too. So we've got that out of the way. The next question, or the most common question asked, was to do with um, visual techniques. Now, one thing I want to clarify is, if I don't know if you looked through the document that was given with or was attached with the entire assignment sheet, but the document I believed was quite clear enough. But I just quickly wanted to go over an example. So, what I'm looking for, so if I'm looking at example one, um, right. So I wanted to go over all the questions. Let's talk about visualization techniques. And I just to clarify things, what I'm expecting of you, or what I expect from the answer is, so there are multiple approaches that you can take. But so let's say visualization techniques, example one, that's what I'm going to go over just to help you guys. The rest should be the examples two and three are they should be easy enough because they are they're more data heavy than anything else. So let's say what I was talking about is, so think about your journey to school this year or the prior years. What is the total distance from your home or bus stop to school? So that's what makes this problem unique to everyone, because the distance that you're going to cover to school is going to be unique to you. Um, and then what I want you to do is, how long does it take for you to reach school every day or to reach home every day? Then you can interpret this data as just one way direction. It doesn't really matter. So you can talk about, you can take the school to home journey and reverse that time as basically that you're coming to school and that you've got one more data point. Um, what I want to do is plot this data. Now, most of you were talking about data points. Let's just say let's do go for 10 data points. So take some data points from the winter, take some from the fall, from the spring, from the summer, or from nowadays that you've been coming to school since orientation. So that should give you plenty of data points. So what I've done here is I've gone into, so for example, I stay about 2 miles from school. So I'm about living near University of Dayton. So the total distance is 2 miles, right? And it can take me anywhere from, so the quickest I've reached school is 6 minutes. The most it's taken me is usually 15 minutes to get to school, right? This is journey that I'm talking about. So what I'm doing is, so let's say I've opened up Google Maps and I've mapped out the distance. So these are a few of the routes that I can take. So you're welcome to do this. You can, if you don't know the total distance, open up Google Maps, plot the distance, look at the distance you normally, or the journey usually do, or the route you usually take, um, and just think about the different times that it might have taken you. So now I can go through this blue highlighted journey, which is 1.2. This one's 1.5. This other one is 1.7 miles. I can also go ahead and take, let's say, this journey through Brown Street, which is 1.4 miles, or Warren Street, I can also go through this one through State Route 35, and that's 2.7 miles. So there are quite a few journeys that I can do. So what I've done here is I've opened this up in Google Spreadsheet. So what I can do now is let's type it up. So I've got the smallest journey is 1.2 miles, which is the most common one I take. Sometimes I go the longer distance, which is about 1.5 miles. The other times when or some road work going on, I crossed the bridge and took that journey. And then there are times when I take the Brown Street to get to the school. Now, mostly it's taken me, so the 1.2 ones, it's let's say 6, 7, 8 minutes. So I can do that. Well, the 1.5 mile journey has taken me 15 minutes. The Brown Street one, because there are a lot more traffic signals, it can take me 15 minutes mostly. So what you see here, or let's say 12 minutes, I'm just varying the data. Um, what you can do now is there are multiple ways of presenting this data. One thing I can do now is I can highlight all of this, and I can go on to insert, and I can say insert a chart. If you don't know how to do that, that should help you now. And it's automatically produced a line plot. Now, what you notice here is there's no X data. What I can do then here is it's giving me this. I can add the x-axis data. I click on C2, C7. What that's done is it's plotted time against time. That's why you get a straight line. What I can do now is I can change here, go to my uh, y-axis, click on this little button, and I can change this manually to B2 to B7. It doesn't matter if you do caps lock or not, and click OK. Right now, what do you notice here? What's happened? Well, something's changed around here. It's giving me a distance time, although it's stating something different. Uh, I'm going to change this to distance. But see, this is the thing that I was talking about yesterday. When you do line plots, because my data has been generated at random now, and it's not in ascending or descending order, what you see here is that these data points are following this line, and once it reduces, it reverts back to it. To fix this, what I can do then is I can go to setup, um, and instead of doing this, I can do a scatter plot right here. Right, and now what this gives me is this gives me a good solid view of how these things are varying. What I can also do is I can go and select a column chart. Now it's doing distance versus the time it took me. Does this make sense? Not really. I could do one thing I could do now is um, I can do distance and time bar charts against the number of days. That might be better, but I will let you figure that out on how to do that. Now, for the second part of the question one. Again, I'm not going to go over example two and example three. You've got entire class period tomorrow to go over this, but essentially for part two of example one, um, I'm talking about speed, right? So in this case, the first time you did it was for distance versus time, and you can do it differently. It all depends how you want to show me the data, but I want 10 data points for part one of example one. For part two of example one, it states that now imagine your journey to school today. How many times did the car stop? On average, how much time was the car not moving? So think about those things. Just try to imagine that. On the other hand, while the car was moving, how much speed did you reach? Uh, think about the entire journey to school today, paying close attention to the total time the car was moving or at halt, and then plot this data using a suitable visualization technique. So, for example, let's take my journey where I go through US or Route 35, right? State Route 35, or is it 4? I don't know, but let's talk about that one. Um, So I start, if I were to plot this thing in terms of speed versus time, right? So I do speed, uh, I do miles per hour, and time is going to be in seconds, right? So I do all of this. My journey is going to start at zero. My speed is going to start at zero. I can extend this column to what I can do then is, um, because I've parked in a parking lot, I usually reverse that. So my speed is going to be moving, right? We're not talking about velocity here, so we're talking about speed, and we'll get more into velocity versus speed. What's the difference when we get to the next chapter? But my speed increases, time's moving. Then I stop, time's still moving. Then I put my car into gear and I start moving forwards, right? So my speed increases, then it comes becomes static, right? Sorry, let me do this again. So I reverse out of my garage or parking lot, right? The speed reduces to zero, and I'm still continuing. Time still passing. Then I shift to forward speed, start moving, reach some speed. Let's say 20 miles per hour because it's a back alleyway that I'm coming out of, and then it becomes static. Once it reaches 20 miles per hour, then at the end of the road there's a stop sign. Speed reduces down to zero. Time still moving, so time still increasing. Then I move on to the main road. I accelerate up to 30 miles per hour, at which point it becomes kind of static, right? So I'm following the speed limit mostly. Then if the traffic light's clear or green, I'll keep continuing forward. If the traffic light's red, so I get one traffic light here, second traffic light here. So right. So what you're seeing here is that I've got one data point, starting point, reverse, halt when I move into so my forward speed, then another one with a stop sign, and there's another one around here, right? So this is not the stop sign. Sorry, this is when I reach my top speed for that road. Um, and then there's the stop sign, speed decreases, and I start moving again, reach the normal speed. Traffic light one, traffic light two. Let's say if this was red, it will decrease and it will continue on forward. So right. So this is what I want you to do. You can have your time in seconds. You can have your time in, or let's say minutes, whichever one you want to do. You can do hours as well, until I reach school where it kind of flattens off. That now that's something I was expecting out of it. But for that, what you'll need to do is you'll need to put in the normal speed that you're getting up to. So if you're going at 70 miles per hour, that's fine. Use that. If you're doing 40, if you're doing 50, that's all up to you. If you're stopping to pick a friend up or carpooling, that's fine. If you're going on a bus stop and the bus stops at every bus stop or whenever it reaches a stop, then yeah, stop, include that into it because that's going to be unique to you and you can do that. Um, so that's what I wanted you to do, and keep these, and we will use these and both of these in the next chapter. I hope that clarifies things. But if it doesn't, please send me an email or let Miss Dawkins know, and she'll let me know through email at the end of the day. If you send me an email, I'll try to be quick, and I'll usually get that sent back to you as soon as possible. Today was a bad day. I couldn't check my email or reply to your emails. Usually, I'm much quicker than this, so I apologize for that. Right. So the last thing I wanted to talk about, or people had questions about, was dimensional analysis, and more importantly, what were the steps that we talked about. So I'm going to repeat, let's say, the volume example again. So if I were going to ask you that you show me how to work on volume, um, what I want you to do is, again, draw a cuboid or cube here, right? If I do a cube in this case, the dimensions of the cubes are same, right? All the sides are the same, so it's going to be for the height, A for the width, and A for the length, although this doesn't match, but essentially you do this, right, which shows that all the sides are equal. So for the volume, the formula for a cube is you multiply all the sides together. So it's A times A, which is going to be A cubed. And if this was centimeter, then it's going to be centimeter cubed, right? Um, so again, if I was going to, I'm asking you for weight. Um, what is weight? Weight is when uh, mass is being attracted by gravitational acceleration here on Earth. So you do normal diagram, you plot the direction it's being attracted. So this has got some mass, let's say m kilograms. What are the units of gravity that I will leave for you to find? And then weight is essentially, you can find this formula and you can find this on Wikipedia as well, but it's mg. So what are the units going to be in this case? And similarly, you had to do it for, I believe, acceleration too. Gravity is acceleration, and you had to do one for energy as well, if I remember correctly. If it doesn't say it on the slide, then don't do it for the energy part. But that's all you had to do. You had to show me all these steps. And you had to show me a little diagram of what the acceleration is, or what weight is, or all of those things. And you can find quite a few diagrams on the internet for that, and you can just use that and sketch that into it. I hope that clarifies things.